You're okay. I will begin with a word of prayer. Ahem. 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 If I have to, I'll bring my whistle. All right. Dear Heavenly Father, we thank you for this day. I thank you for these students and their friendliness to one another. Help them to pay attention to this class and help us to cover good math today and to understand your creation a little bit more, Lord. In your name I pray, Lord Jesus. Amen. Amen. All right. So let us begin. Now, if you have a laptop out and you're doing something other than math, then you should just leave. Like, don't be here. Be somewhere else looking at the laptop. You don't need to be here looking at the laptop. You could be somewhere else looking at the laptop, and it would all be the same to me. But you would then not be distracting your classmates, which would be, preferential. Anyway, you guys get the idea. So today, we're talking about absolute value and inequalities, which is section 1.8 in your textbook. I offered my son $5 whole to scan the homework pages in the textbook and convert them to PDFs. So, soon, because my son loves money, there will be PDFs of the homeworks. I will post them in Canvas, and then, hooray, right? Then you won't even have to find my office. So I'm working on that, all right? I'm working on that. I should say my son is working on it for filthy lucre. That's money. But today we're talking about absolute value, and I guess to start with, I should ask you, what is absolute value? So if I asked you absolute value of x, what's the formula for it? Yep.
The absolute value is how far something away is from zero.
Oh, you say it's the distance from the origin?
Yes.
Distance of x from origin. That's a very geometric answer. You're not wrong. What's a formula for it, though? How about this? It is the square root of x squared. See, square root is by definition non-negative. So this is always positive. It's only 0 if it's 0. This is, in fact, a stone-cold formula for absolute value. Now, of course, we can also write it as a case-wise defined function. It's minus x if x is less than or equal to 0. It's x if x is greater than or equal to 0. These are all equivalent statements, all right? This is absolute value. Let me keep it real simple here. Example 1. What is the absolute value of 5? Well, the square root of 5 squared, right? Which is the square root of 25, which you guys can recognize is 5. What's the absolute value of minus 5? See how that goes. Square root of minus 5, quantity squared. How's that go? Well, square root of 25, and guess what? Still 5. So this is the magic of the square root of the square function. This is the absolute value. All right? There are various properties of absolute value. For instance, if we have absolute value of x times y, how's that go? That's the square root of xy squared, right? Which is the square root of x squared y squared, which, lo and behold, by properties of the square root, is square root of x squared times the square root of y squared, which is, guess what? Absolute value of x times the absolute value of y. So the absolute value of a product is the product of the absolute values. That's a nice property to know about for absolute value. We'll use that from time to time. The other thing nice to notice about absolute value is it eats minuses, right? Like, it's pretty easy to see that the absolute value of minus x is equal to absolute value of x, right? The absolute value just destroys minuses. What else can you tell me about absolute values? How about this? The absolute value of x plus y is equal to the absolute value of x plus the absolute value of y, right? For example, the absolute value of 7 minus 4 is equal to the absolute value of 7 plus the absolute value of minus 4. Because the absolute value of 3, which is, by the way, 3, is equal to 7 plus 4, which is equal to 11. Everyone knows that 3 is equal to 11. this literary device I'm currently using is known as sarcasm, right? So the Sunday school curriculum we were using, it's always like, what type of literature is this? I'm like, I just don't like this question. Like, let's talk about what the Bible means. Let's not try to like say it's this kind of literature or that kind of literature is dumb. So no, this is not true. The absolute value of a sum is not the sum of the absolute values, usually. All right? There are other things you can say, but that's not one of them. All right, so product, fine, sum, no. All right? Okay, so example 2. Suppose we want to solve the absolute value of 3x minus 1 equals to 7. How would we solve such an equation? So what does that mean? There's two possibilities here, right? What are the two possibilities for solving this? What's the one way? Either, there's, you know those choose your own adventure books? You know what I'm talking about? Okay, cool. They're still making those, good. And then you got 3x minus 1 equals to what? What's the other way you could have this work out? What if 3x minus 1 wasn't equal to 7? What if 3x minus 1 was equal to minus 7, right? That would give you a way to solve the equation. So you have these are two different paths you can go down, right? In the end, it's still the same road we're on, but that's 3x equals to 8. And over here, we've got what? 3x equals to, what's minus 7 plus 1? It's minus 6, right? So what does this give us? Two answers, right? X equals to 8/3, and x equals to minus 6 over 3, also known as minus 2. So there you go. These are the answers. There are two solutions in this case, right? Are we good so far? So when we're solving an absolute value problem, we should expect there could be two solutions, right? Does there have to be two solutions? No, there doesn't have to be two solutions. Check out this for an example. Example 3, absolute value of 2x. I'll get it eventually here. 2x plus 17 equals to minus 53. So here, there's no calculation to do in this problem. In this problem, you just need to think about your life. Think about what's the property of the absolute value function, which I probably should have written down. My bad. My apologies to those of you who were not here. That's the example we were working on. Sometimes I'm my own worst cameraman. What can I tell you? So one of the, crucial, perhaps one of the preeminent properties. I got no red marker in here. Oh man. That's a bummer. I got a laser. I got a pink marker. All right. But, so the absolute value of stuff, all right, is greater than or equal to 0. By construction, absolute value is non-negative. Could be 0, could be positive, can't be negative. So look at the example 3. Do you need to do any calculation here? You do not. You just look at it and go, that's impossible. I can't have absolute value equal to minus 53. So, impossible. No solution. Now you might feel like, that seems too easy. This must be a trap, right? But this can happen. Example 4. What if we have like more than one absolute? Yeah. Oh, it's done? We're all good? Everyone who's attended has attended? Names have been named? Checks have been marked? Signatures signed? I could start naming the people who are. Anybody not get this already?
Oh, I.
There you go.
Oh.
I know you were here today. I talked to you before.
MC.
Very good. Thank you, Mike. So the other thing we might come up against is something like, oh, I don't know. You could have something like x plus the absolute value of x minus 3 equals to 10. We could try to solve an equation like this, right? This could happen to us. Is there one solution? Is there no solutions? Are there two solutions? I honestly don't know until I work it out. Okay? So there's two cases, right? What are the two cases? You either have, the absolute value of x minus 3 equals to x minus 3, or what's the other thing that could happen? You could have minus that, right? So either the quantity x minus 3 is positive or the quantity x minus 3 is negative. Them's your choices. So those are the two paths to go down. Those are the two solutions to try to seek. So let's do it. We got x plus x minus 3 equals to 10 on the one hand. But on the other hand, we've got x minus 3 equals to 10 over here. Can we solve these? Ooh, here's a color even more hideous than pink. Carolina blue. Carolina. I always throw up in my mouth a little bit just saying it. Are you guys like UNC Chapel Hill? Duke's okay. Duke's fine. But Chapel Hill, no. My PhD is from NC State. I also went undergrad at NC State. So it's a rule that I have to hate them. Am I from North Carolina? I mean, I've lived in North Carolina some time. Am I from North Carolina? No. I'm a Yankee. I grew up in upstate New York, a town called Vestal, which happens to be where SUNY Binghamton is. Oh, excuse me, the University of Binghamton, because they're fancy now. But when Mom was little, it was just cow fields there. Anyway, so how about the other one? What happens there? Ooh, x's cancel, right? And that leaves us with 3 equals to 10, which is a hard pill to swallow, right? Like, no, you can't do that, right? 3 is not equal to 10. No sir, no how. No solution over here, right? Why is this happening? Let me just take a second and I don't think we really talk about this part of the course. I don't talk about the geometry of the absolute value directly in terms of graphing the absolute value function, but later in the course. So this is a flash forward, all right? A flash forward to graphing function involving absolute value. So I'm just going to tell you right now, if we look at y equals to the absolute value of x minus 3, and then we can look at y equals to, say, 10 minus x, right? This equation up here is the same as what? It's the same as absolute value of x minus 3 equals to 10 minus x, right? So if you want to think about this equation graphically, you can think about it as the points of intersection between the graph of the absolute value of x minus 3 and the line with slope minus 1, which has y-intercept 10. The graph of those two things looks like about these. So x equals to 3, absolute value of 3 is actually a v. It has a y-intercept of 3. Oh, I'm sorry, I'm still using this hideous Carolina blue. I'll stop in a second. Oh man, poor choice on my part. Poor choice. This is 3. Where's the y-intercept for the other one? It's like, man, where's my red? Oh, fine. So annoying. I left it in the other room. I know what happened. It's all my fault. So up here is the 10. The slope is minus 1 on this one, right? So slope of minus 1 looks something like about this, roughly speaking. I should probably go get my thing. And so what happens here is, on the one hand, you got slope. Wait, that's not slope minus 1. I'm an idiot. What's slope minus 1? Good grief! No, you have to admit. I'm sorry. We live in a country full of lies. The principal lie is that everybody can do everything. It's just not true. We all have different talents. We're talented by God in different ways, and we shouldn't presuppose that we have the same talents everybody else does, because we're all made as individuals, and we all have our unique set of talents, and we should embrace that and not say that we're all the same, because that's just a lie, and it's a stupid lie, right? If I'm 5'3", I'm not an NBA star, probably, right? And we could go down the list of things like this. But anyway, if you're deathly afraid of numbers for some reason, you shouldn't be a mathematician, right? Like, some people are like, they wake up at night, they see a 7, they're like, ah! I don't know. I've heard people have math phobia. I think math phobia is actually something else, but it's fun to think about. So my point to you is, this line, these two lines are what? They both have slope minus 1, actually. They're parallel, they never intersect. There's no solution over here. There's a unique solution right here. It happens to be at 6.5. 13 halves. So that's why there's just one solution here. If you think about that other problem I just worked over there graphically, it's something like the absolute value function. If you were to graph it, it's above the x-axis. The thing you're trying to intersect with is below the x-axis. They never intersect. On the other hand, this problem, it's something like, graphically, it's something like this, guys. The absolute value function looks like this, and your other line is like this, so you got two solutions. Like, that's pretty much what's going on. That's why we have either two solutions, one solution, or no solution for these problems. Yes, sir?
Can you explain what both the blue and magenta lines represent again?
Oh, yeah, my bad. This is y equals to 10 minus x. The blue, the hideous Carolina blue, is this guy right here. So the absolute value functions give you like a v, and, well, lines are lines. So that's it, guys. Solving problems with absolute value, all you got to do is look at the plus, look at the minus, treat them separately, solve your equations. Is good?
Oh, wait. But how did you find the points with the absolute value equation?
Oh, how did I find these points?
Yeah.
I solved the equation, so I had like x minus 3 equals absolute value x minus 3, so I just, this here, I put here, right? And then I solve it. I've got 2x plus x is 2x minus 3, so I get 2x equals 13. We divide by 2. So the same thing we did first day. Over here, the other case, it would be absolute value of x is minus the thing. Again, I plug it in right here. And then I try to do the math, but when I do, I find out I've got an inconsistent equation. I've got 3 equals to 10, which means there's no solution. So what I was just talking about is geometrically that's corresponding.
So y is 3.
So y is 3.
It's absolute value x minus 3, yes.
Yeah. What is it? Y equal to?
Equals to 3.
Well, there is no y in this problem. I made up y for the sake of graphing these two equations and thinking.
So it's much more difficult.
Well, you don't have to graph anything. We can just solve it like we were doing in example 2 and example 3. Just look at x and try to solve.
Oh.
This really is a comment from the future. This is like from.
So I wrote it down anyway.
That's good. I said it in class. It's not wrong to write it down. We will come back to this idea later. I'm just trying to explain to you guys why we're finding what we're finding, why there's either 0 solutions, 2 solutions, or 1 solution. That's all. Telling you why doesn't help you find it, right? Nobody wants to graph these things to find the point of intersection as the solution, right? I don't. Do you? I don't. All right. So with that settled, we're going on to something scarier. Ooh, scarier, you say. Yes, scarier. Inequalities. Ooh. Ah. Inequalities. We need to talk about how to solve inequalities. Now, I said I'm covering section 1.8 today, and that's true. I am covering section 1.8. But probably the really basic inequality stuff is probably in an earlier section. Like, I don't know right off the top of my head. I don't have the book on me, but I think the kind of inequalities I'm about to solve are actually in an earlier section. Okay, guys. So the harder inequalities are in section 1.8, and we'll get to those. But before we do the hard ones, let's talk about the easy ones because it'll help us to start the conversation where it needs to be. Let's just do a real simple one. Example 5. Suppose you want to solve the inequality 3x minus 1 equals 2, not equals 2, inequality, right? Less than 5. To solve an inequality, we have to give the set of all x which make this inequality true, right? So what can we do? We can add 1 to both sides. What's that give us?
3x
Less than 6. What else can I do with an inequality? I can divide by a number, right? If that number is positive, we just divide by it. So dividing by 3, I get 3x over 3 is less than 6 over 3, which is to say x is less than 2. So that right there is one description of the solution. Now, but I usually, in order to be malevolent and mean-spirited, as is my job as a math professor, right? I ask for you to write the answer in terms of interval notation. So interval notation is somewhat based on the number line. So if this is 2, right, where is x? So x is like over here somewhere, right? And so we could draw it like this if you want, right? But the point is x is in the interval from minus infinity to 2, not included. So this right here is the solution in interval notation. Solution in interval notation. Solution in interval notation. I can't spell. Interval. I tried. Interval notation. Shall we look? Let's look at another one, yeah? Example 6. I might have something like, I don't know, 2 less than or equal to, let's say, 3 minus 2x less than, I don't know, 10. This is a compound inequality. It's 2 inequalities at once. Am I right? And we can solve compound inequalities by the same general set of tricks that we can solve just single inequalities. So what do you want to do? I think we should subtract 3, right? Let's subtract 3 across this. We can do that. So subtract 3 here, I subtract 3 there, I subtract 3 there. Wait, we subtract 3 across the whole thing. So that gives us minus 1 less than or equal to minus 2x less than 7. We want to isolate x, right? Now here's where it gets a little dodgy. I've got that minus 2. When you divide by minus 2, you must remember division by a negative number or multiplication by a negative number flips the inequalities. So less than becomes greater than. So when I divide by minus 2, that becomes greater than or equal to minus 2x over minus 2, greater than 7 over minus 2. In other words, what we have is minus 1/2 is greater than or equal to x is greater than minus 7/2. For me, writing inequalities in terms of greater than is awkward. I prefer to write inequalities in terms of less than, because that's sort of how we read things grammatically, left to right, you know? And this just sort of works against that. So any inequality involving greater than, we can rewrite as a less than inequality. How do we do it?
Use the opposite integer of everything else.
Right, you just... So this is the same, logically, as minus 7/2 less than x, less than or equal to minus 1/2. You notice that I've changed the order. What does this mean? Graphically, if we think about the number line, you've got your minus 7/2. And minus 7/2 is really what? If I use decimals, it's what? Minus 3.5, right? And then you've got your and I should really write like a parenthesis kind of thing here. Honestly, let me use the other notation. So there's really two competing notations. The one notation is like an open circle. Open circle says the point's not included, all right? And then the closed circle, like a so, it says the point's included. So that's like minus 0.5. So that's minus 0.5. This is minus 3.5, if you allow me this small manga style comment. I'm sorry, manga style. What's wrong with me? Yes?
So I have a question. So
Go for it.
For the negative 1/2, why didn't you divide that by negative 2? Shouldn't you positive 1/2?
Oh, what have I done?
1/2.
Oh, man. Goodness gracious. Thank you. All right. Let me just sit over here and give you guys a second to fix it. Thank you. I appreciate that comment now, not 3 minutes from now. That's better. As soon as you see something like that, though, interrupt me, please. Because what has happened is you realized that 2 minutes ago, and then you confirmed with your friend before telling me, yes? Yeah.
Well, I was working it out positive the whole time. And
Oh, cool. Hey, that's even better. So she's saying she's working it out herself, and then she's like coming back and checking in with me if I got the same answer as her. That's excellent. That's a good way. I visited my brother once at college. He went to Bob Jones, and it was like during Thanksgiving break, so I just went. I'm sitting in this class, right? The professor's working something out. And like my brother's like taking notes, right? But he's working something out, and he figures out that there's like 2 possible answers to the thing the professor's working on. I'm like, why didn't you tell him? And Bill's like, shh, give it a minute. And then sure enough, Dr. Guthrie's like, if you can tell me the other answer, it's worth a bonus point. And I'm like, oh, I see. So there are, yes, anyway.
So when you subtracted 3, so minus 3.
Yep.
So why did you subtract 3? What does that mean?
Well, it's a property of inequalities. So if I have A is less than or equal to B, one of the properties of inequalities is that I can subtract C from both sides. So this is an allowed operation on inequalities. And the same is true if I've got, 2 of them. So what I'm doing is I'm subtracting C on both sides. This is something we can do. It doesn't change the truth value of the inequality. It's
Minus C is greater than B minus C.
right.
So here, can I show you for a minute?
If you want to show me on the sideboard, you can.
So it's
I'll let
So
you, yeah.
it's 2 minus 2x squared and 10. So A is B. So 2 is the A.
Right, yeah.
2x is the B, and
Oh, think of this all together as the A, and this all together as the B.
this is the C.
Well, this is something else altogether. Maybe call it D. See, I also have B is less than D, and so it's also true that B minus C is less than D minus C. So I'm subtracting C from. When we work a compound inequality, we're working two inequalities at once. So like the C is 3. I'm subtracting 3 from both sides.
Oh, so
C is 3 in here. I'm subtracting 3 from here, and from here.
oh,
Uh-huh.
2 minus 3 and 10 minus 3.
That's right. That gives
So,
us.
The number in the center without the x is the C.
Yeah, well, the number in the middle, the C cancels. 3 and minus 3 is 0. It's gone. And all that we're left with is the minus 2x term. See,
So we need to keep the x.
right. Our goal with inequalities, just like it was with equalities, is to isolate x. It's just that we have to be careful. With equations, we could multiply or divide by a number without worrying, right? But now, if we multiply by a number, it's fine. The inequality is preserved. But if we multiply by a negative number or divide by a negative number, the inequalities reverse, switch. Yeah. Now,
With the negative, flip the sign.
that's right. So to complete the thought here, where is the x? Where is x? X is here, right?
Oh, in the middle.
It's in the middle. So the solution here is, in interval notation, it's equal to.
Thanks, Professor.
You're welcome, Mike. Or is it Michael or Mike?
Michael.
Michael. Yes, you're welcome, Michael. So 3.5 not included to 0.5 included. This is the solution set in interval notation. All right? So when I ask you for interval notation, this is what I'm talking about. Now, sometimes the solution set's more interesting. It's not just one interval. It's like 2 separate intervals, and you have to use what's called a union of 2 intervals to get the solution set, right? We'll see that in an upcoming example. Now, I'm so happy that you told me the absolute value was distance from the origin, because that is so important to what we're about to do. Yeah. See, because I want to set us up to understand what we're doing in terms of that idea, distance from the origin. And what I'm going to do is I'm just going to develop for us a fundamental lemma, if you will, a fundamental truth, which is based on, and we're going to use like the letter A, so we can make a substitution into that later, okay? So check this out. If we had that the absolute value of A, right, is less than some number, let's call it delta. Now delta is just a Greek letter, right? So some positive delta. What's this mean? This means that if we draw a picture, right, this says what? Distance of A from origin is what? Is at most. Did you guys not like the delta? Is that bothering you? Tell you what. Here we go. D. Feel better? All right. I won't tell my Greek friends. I think I really just have one Greek friend at this point. I used to have 2 genuinely Greek friends. They're a lot of fun. The one could make the moussaka. That moussaka, that's good stuff. Anyway, so the distance of A from the origin is at most D. So if you draw a picture right? If we draw a picture, and this is the origin, where does A have to be? If I put A here, where does it have to be? Where can it not get past? It's pretty simple, right? D, right? If D is positive, and it is because what I just said here, so it's got to be before D, and it's got to be, it's got to be to the left of D and to the right of minus D, right? Can we put that in an inequality? Well, this means that minus D is less than A is less than D, right? Does that make sense? So that's, in other words, this inequality with absolute value is equivalent to this inequality without absolute value. So we can get rid of absolute value with a less than by unwrapping it like this. On the other hand, if we have the absolute value of A is greater than D, what's that mean? Oh, I'm sorry. My apologies. The hideous Carolina blue has come back. I had to throw that thing out. Where does A have to be in this situation? This means that the distance from the origin to A is what? It is more than D. Greater than D. So it can't be where it was before, right? Now where does A have to be? A has to either be over here, right? Or it has to be over here. So over there would be to say that A is greater than D, right? Over here would be to say that A is less than minus D. So in other words, A is in minus infinity to minus D, or A is an element of A D to infinity. Let me rewrite this. So in other words, we either have A is less than minus D, or A is greater than D. Yep.
The D that we're using is just representing the delta, right?
Yeah, the D is the delta. It's the positive distance of discussion, whatever that might. No. So, let me rewrite this all as just a compact lemma for us to reference and use and stuff. I would encourage you to, put this on your formula sheet. You want to learn how to use it. So this is the lemma, which is simply this: A less than D is equivalent to minus D less than A less than D. Absolute value of A greater than D is equivalent to A less than minus D or A greater than D. And I would emphasize that those are disjoint cases. You cannot have both A is greater than D and A is less than minus D. Those are separate cases, right? Those are separate cases. And just, these are not the same. Less than and greater than are fundamentally different for the absolute value problem. The solution sets look very different. The greater than problem tends to make you use a union for your solution. The less than problem does not. So let's look at an example. Now that we've got this backdrop to hang our hat on. So before I go back and move my camera, let me write the example, see if you guys can solve it. So let's see, we're on example 7. Suppose you want to solve the absolute value of 3x minus 1 is less than 2. Find the solution set for that, write it in interval notation, right? How should you do it? Which case are we in? We're in the less than case, right? So we want to get rid of absolute value. How do we do it? We simply right. Well, we can do it all at once though. See this? We think of this right here as our A, right? Make a substitution. Think of that as the a, right? And so we have minus 2 less than a less than 2. That's equivalent to the given inequality. But we don't want to look at a, right? We go back to x, right? And indeed, once you understand what you're doing, you don't have to write the part I wrote in blue down. You can go straight to the part I wrote in black, right? It's fine. And you solve it. How do you solve that? We solve that the same way we solved example, 6, but this is easier because there's no minus in the x. So we just add 1 across it, add 1 to everything, plus a 1, plus 1, plus a 1. Minus 2 plus 1 is minus 1. 3x is less than 3. Well, again, the goal, as usual, isolate x. Now what? Divide by 3. So we have minus 1/3 less than x less than 1. So the solution is equal to minus 1/3 comma 1. And the endpoints are not included because these are so-called strict inequalities, right? If I had less than or equal to instead of less than, then I would end up including the endpoints with inequality. Let's look at let me do example 8 here. What if we had 3x minus 1 greater than or equal to 2? How would we solve this? Notice this is not absolute value less than. This is absolute value greater than. So that puts us in the more troublesome case of the lemma, right? There are 2 separate cases to investigate here. We either have a is less than minus 2 or a is greater than 2, where my, a here is my 3x minus 1, right? So I either have 3x minus 1, and notice, so guys, I threw in an equality here. So if there's like an equality, it just transfers to both sides, okay? I didn't want to write like 4 cases, because if I write 4 cases, you got to be like, So it's better for me to just say it and do it, as opposed to like making my lemma 4 cases. Actually, there's more cases, because you could have, well, anyway, I'll shut up. So equals on both sides here. So I've got 3x minus 1 less than or equal to minus 2, or I've got 3x minus 1 greater than or equal to 2. These are not the same x's, right? They're actually going to be different x's. So think of it like a Taylor Swift song. There could be more than one x. Sorry, you guys Swifties? I saw an adult man on Twitter the other day announce his Swiftiness, like he was a Swiftie. And first of all, I was like, what's a Swiftie? And then second of all, I was like, oh, why would you say that out loud? Why would you leave a public record of that?
You're on Twitter, so.
There are, X, I'm sorry, excuse me. We're all doing X now. That seems wrong. Yeah. I'm assuming that Elon Musk has changed the name of Twitter to X for much the same reason that Prince once upon a time changed his name to the artist formerly known as Prince. That is expressly to avoid various contractual obligations based on the name Prince or based on the name Twitter, as it happens now. I would assume that's what it is. I don't know. Now I repost things. So exciting. So look, those are not the same x. And it becomes blaringly, just look, divide by 3, x less than or equal to minus 1/3, right? Divide by 3, x greater than or equal to 1. Can you have both of these things at the same time? No. It's like, you guys, many of you are not married, you're trying to find a a suitable helpmate and a partner, whatever you want to, wherever you fall in the egalitarian spectrum as how far you have, mutilated the biblical roles for husband and wife. I don't know. It's up to your business. But you might have to give up on one thing if you want another, right? Like you might have to settle for like a woman who loves Star Wars but is blonde, or maybe you have to doesn't love Star Wars but is brunette. I mean, I don't know. Like you can't have everything at once. You may have to actually, who cares about Star Wars? What am I talking about? But anyway, you? Oh, are we talking about the original Star Wars or like the dumpster fire that's been recently?
The prequels.
The prequels? Now the prequels have gained. All right, it occurs to me I have 3 minutes. Let me try to finish this thought. I'm about to lose the class. I will not say anything about, no, I will not. I will wait till, so this means x is, and I used a symbol, you guys haven't asked me, but some of you are, you have a question in your heart that you just haven't, you're going to come up to me after class and ask me what it means, right? You're planning on it. But so let's just talk about it together. And I don't mind you coming and talk to me after class, although I do have another class to go to. This symbol here, which I sometimes use because I forget I shouldn't. Can I use it, please? It makes me feel better. No. You guys are such, you must be all be Democrats. You're a bunch of censors. Let's see here. Element of.
Getting political.
Oh, I'm sorry. Have the Republicans been censoring people? I don't remember it. I mean, not that I'm a Republican. Good grief. Ugh. They've never found a populist movement they couldn't squash. So, element of. That means it's in the set. I was careful to use the word in over there. I was fighting everything in my being to not say, like, element, X is in. Like, I wanted so much to write element here, but I didn't for you guys. All right? So solution here is what? Minus infinity to minus 1/3 unioned with 1 to infinity. This is the solution. That's union. That means you put it together.
So you're
right?
using both answers as part of one to list what you calculated.
Right, yeah. Yep. And those are it's a disjoint union. Those are not, there's no common point there. Yep.
So is the quiz going to be everything we do every
Oh, no, the quiz is, nothing we've done today is on the quiz. The quiz is all last week. It's 2 equations or 3 equations. Yeah. No, this is not on the quiz. Come on, I'm not a monster. That's the next week's quiz. That's next week's quiz. I gotta go turn off my camera. See you.
The quiz is Wednesday, right?
Yeah, Wednesday there's a quiz. That's true. It's true.